Hello there, astronomy students. I wanted to take a few minutes to give you a little tour of the spreadsheet model. This is the model that you're going to download from Google Classroom. It's just a Google Sheets document. And most of it, you don't, I mean, if you actually scroll down, it has all kinds of scary things in here. But they're all just calculations and equations that the model is solving to compute the flow of radiation, 20-some streams of radiation through 20 layers of the model. But there actually is not that much that you need to mess with. In fact, it's color coded where you're messing with, and actually the only numbers you change are the numbers in these blue cells right here. Okay, and for some of those values, you get off of this table in green what to use. I give you some of the values for Earth, Mars, and Venus, and the output of the model is just the temperature, the average temperature of the surface of the planet, and I give it to you in both Kelvin, in Kelvin and in Celsius and in Fahrenheit. So like, for example, one of the, I think it's project 1 actually, is telling you to go ahead and try to simulate the current atmosphere of the Earth. Now, in the problem, it tells you to take the value from the green table for solar constant, and so 1360, and you're going to put it over here into the input, which is the blue cell. Now, later when you do Mars, you would put 590 from the green table over here. And for Venus, you would put 2636 over here. But the value of the solar constant for Earth is 1,360 watts per square meter. And hey, I have a helper. Hold on. This is Gabriel. Say hi, Gabriel. You are really messy. Gabriel's been eating candy this afternoon. Go play. Go play. Oh, you want to show him your turtle real quick? You want to show him your turtle? Rah. His turtle is currently wearing a Halloween costume. He found the head of the dinosaur. All right. Anyway, moving on. All right. So you would put then the value for Earth's solar constant. You're going to put the value for Earth's albedo. And you're going to put in the value for Earth's TVIS. That's the transmissivity of the atmosphere to visible radiation into this column right here. Remember, that was how much of the visible radiation from the sun makes it through each layer. So every layer of the atmosphere in this model is letting 98% of the visible radiation get through. 2% is being absorbed by clouds or ozone or some of the other gas in the atmosphere. Oh, you're a big helper there, Gabriel. All right. All right. Now, when you actually change these numbers, it'll make calculations happen down here, and you'll get changes to these temperatures here. Well, this is all one temperature, just expressed in different units. And it is much too hot at the present time. We're simulating with these settings right here that the temperature of the Earth is 250 degrees Fahrenheit. The temperature of the Earth is 288 Kelvin. So use the Kelvin for what you're doing, but you can see we're much too hot, over 100 Kelvin hotter than we should be. Now, the only number you play with then is TIR, the transmissivity of layers of the atmosphere to infrared radiation. And you need to play with that. Now, there's instructions on the pages as to how to know whether to go up or down. Since we're too hot, we want more of the radiation from the surface of the Earth to get away. So we want to increase the amount of radiation being transmitted. Let me try 0.6. 60% of the radiation in each layer gets transmitted away off to space. And calculations happen, and well, we made it cooler. It's only 211 here in Kelvin. I know. It's only 200. It's still, though, almost 100 Kelvin too hot. And in fact, we can keep adjusting this. Let's try 0.95. And oh, look, the average temperature of the planet is only 16 degrees Fahrenheit, 264 Kelvin, and it's too cold now. So, okay, we want to let less radiation get away. So we're going to go down to maybe 0.8. And I want you to sort of narrow it down until you get to within whatever range each of the problem tells you. Or later you'll do this for Mars in, I think, Project 2, or then you'll do it for global warming in Project 3. But you're just going to be adjusting. You'll put in the values you need to in for these blue cells, and then you play with this value, up, I'm too high, I'm too low, up, too low, too high, and then you narrow it down until you get the temperature that you want. This is called tuning the model. All right. Well, that's all I needed to show you. I'm going to show you one more thing in the next video about how to make copies of this presentation. And in the meantime, please let me know if you have any questions about any of this. Dad, go.